Whoa. Does that work? Can you hear me now? That's not perfect, but does that work? Hey, I literally just added a new sound source in OBS, but I don't know why it's not working. Oh, okay. This works, right? Can you yeah, now you can hear me. Okay. And this also works. Can you still hear me? Because I'm back to my old sound source. It started working when I made the new one. Hey, thank you so much. I love you guys. Thank you for letting me know. Anyway, let's get into it. Let's get into it. Where was I? We're in todo.org. So last night, thank you so much, guys. I really appreciate you for sticking around. Not just going, this guy's an idiot. Ooh, it's a good morning. Anyways, uh, Simon, I was asking when you got in, I said, thank you for the loves. How are you doing today? What brings you in? And then Good Mallard and Simon the Swede both said, hey, you're muted, buddy. Uh, I'm glad I could fix it. Anyway, whew, always love that like live stress. You know what I mean? That's the best part about live streams. It's like if anything goes wrong, it's like, oh, I'm fixing it. Ah, fuck. Does it work? Oh shit. There's so much stress. In any case, we have Code Generation by Douglas Thane. He made this awesome video, which I linked in chat. I don't know if you can see it if you were here back then. Can always link it again if you need it. And it'll be in the description of the YouTube video. But you can see that this video is actually like an amazing insight into how code generators can be built. And it has like simple code gen steps that I think we can follow. And then I wrote a bunch of notes about like what that would mean. And yeah, I wrote a little bit of code. I cheated a little bit, but it's not in the file and it's not like complete or anything. So I figured it was fine. And I also wrote this morning, like 30 minutes ago, thinking about how to implement register allocation. And we also need to add a result register or something to our parser node, if that makes sense. Yeah. Or we have to like convert parsing nodes into new nodes, but I don't want to do that. So we're just going to add it to the parsing node. Alrighty, I think that's a good start. Let's we have everything staged in Git, right? Not staged, but committed. Everything code-wise, yep. So we can just go ahead and, oh wait, did I see something in source not committed? Code.s, my test, and test.s. Okay, that's fine. Everything's fine. I panicked a little bit. I'm like, wait, something from the source isn't even tracked. So let's go to the source and just delete. What should we delete? We should delete CodeGen.c, and we're going to delete CodeGen with source CodeGen.h. And look at that. So much better. Okay, now let's do this the right way. Alrighty, so in CodeGen.h, that's good enough for me. And in CodeGen.c, whoops, that's what I get. That should be fine. Why are you complaining? In any case, we should try and build our thing. We have to do it from here. And run it. And give it an example file. Wonderful. This is all perfect because we removed all the CodeGen stuff. That is just fine. So what we would like to do is in CodeGen.h, let's think about our external API. So we're going to have this, I think, a register descriptor, and it's just going to be an integer. And I think that's going to be an index into a linked list or something. So let's do another type def. This is going to be a structure. And let's just call this a register for now. I think that's fine. Nolan says, hey, how's it going, Nolan? What's going on? We are just beginning our work on the new code generator. We deleted our files and we've started work anew. We may go back and steal these file helpers, but we may not. How are you doing, Nolan? Good, Mallard? How are you doing? Simon the Swede? So this is going to be name. This is going to be what will be emitted when referencing this register, i.e. rats. Good enough. Okay, what else do we have? We have a name for a register. We also want a marker for whether it's in use or not. Nolan says, I'm well, thanks, packing for my holiday. That's awesome. You're going on vacation? That sounds fun. My vacation is like I make it to the corner store, the convenience store down the road, you know what I mean? And I'm like, damn, I really made it this far. If non-zero, this register is not able to be allocated. Is already in use. I mean, this is kind of, I don't think we need this, but whatever. The comment, that is. We definitely need this marker. Nolan says headed to the remote countryside for a week. Oh, that's cool. That's very cool. That sounds calming. Not so hectic. I think this is all we need, question mark. This should be all we need. And then while codegenning, we're going to have like register allocate or something. So let's just do that, and that'll return a register descriptor. It's going to take a register pointer base, and then well, this just needs to return a register. I guess we could just do this. I see. Then what we can do, we can have register name, which takes in a register base as well, but then a register descriptor returns a char pointer. Yeah. So I guess we can just do while base, loop over the whole thing, base equals base next. And then we can say that our register descriptor, that's a little bit of a long name, but it's fine. Do that or that. And then go with that one. Okie doke. Okie doke. So we have this register, and if while base. Yep. And then I think we just say register descriptor minus minus. Register descriptor less than or equal to 0. then we can return base name. Does this make sense? So when we allocate a register, we should say, okay, while base. It's kind of confusing to call it base, but it's kind of necessary. Also, I know I'm writing this in the header. I'll fix it. So we have the base, and we would like to say base equals base next. And then we want to say if base in use equals 0, then it's not in use, and we can say base in use equals 1, return, we're going to need our register descriptor, right? And this will be R. Well, we'll just make this register descriptor. Why not? We'll keep it consistent, right? Awesome, awesome. And then every time we do this, the register descriptor is simply, this is going to be like a big error. And it's going to say like, hey, you can't do this. Cannot allocate enough registers. Cannot allocate register. So we'll do like error register allocate or something. I think that's good. So this is just going to return a descriptor from an already existing list of registers and give us the first one that is free or panic. Not too bad. I don't think that's insane. Register name takes an existing list of registers and a descriptor and gets the name of it. I don't think that's too insane. We just need a way to say I guess register create, right? And then we can just say we could also have like void register add to end. I don't know why we need to add to the end. I don't think that's important. We can just add to the head and return the register. We'll add to the end so we don't have to change things. Not have to do any pointer swapping. So register create is going to malloc a register. Why not calloc it so it's 0? 1 register, please. And give us this pointer. And we do this everywhere else. So we're just going to do it here. We're going to assert R and say could not allocate memory for register. And if this happens, we're in really big trouble in other places because we can't even allocate, like, what is this? 16, 17 bytes? It'd probably be, it's 12. Look at that, 12 bytes. So this takes up 4 bytes, even though these, interesting. In any case, we can allocate and return this register. And we'll take in, I guess we'll take in a name and a thing. Yeah, we'll take in a name. I guess that's all we need. Or we could just set this ourselves, but we'll do it. We'll do it. Our name equals Stradoop name. Why not? And say, we're going to assert name too. No, it's fine. We'll just assume that we pass. We're good boys. So we can create a new register. We can take an existing register and add a new register to it. Maybe this should just use name directly. Name is now owned by register. Good enough. So register add, we have to have a base is how we did this. I'm going to say while base. And we're also going to need a name. So we'll do while base next, base equals base next. And that'll get us to the end of the list, basically. Then we can just say base next equals register create name. And do the same thing there. I think that works. So we just go to the end of the list and then say the next one is equal to a new register. Works for me, works for me. All right, so we have this little bit of API now. So we can create new registers, create the first register, create new registers after that. We should probably think about freeing them, even though it doesn't matter, right? And base. We'll say toFree equals base. Base equals base next, I would say. And then we should say free, first of all, base name. But only do that if there's a name, just to really safeguard things. So if there's a name, free it. So while base, we can dereference it. Base equals base next, then we check again. So what we can do is then free to free because we are done dereferencing it. And we'll only do that. I guess. Why are you mad? Oh, you don't exist in the header. That's okay. That's okay for now. So we free the base after setting base to base next. So our last dereference free get out. Okay. I think that makes sense. We can free a whole list as we go. That's good enough for me. Good enough for me. And now we just need to actually move these into their proper files. Like this. Register create. Register add. Register free. And register allocate. Oh, and register name. And then we're also going to need like void register deallocate. Yep. Whoops. So let's write that really quick and think about, should probably go next to, should probably go next to allocate. What's wrong with register name? Oh, I didn't get rid of this. Sure. All right, register deallocate. We would like to say while base equals base next, and register descriptor minus minus, register descriptor equals 0, return, I guess no, we just have to set base in use to 0, and return, because we're done. And then here we'll just say error, register deallocate. Could not deallocate register. Blah. And then we'll give the descriptor. Is that 4? Good enough for me. And like exit 1, I guess. It doesn't really matter. So we register deallocate, which means we have a register descriptor. If it's 0, we'll just use the first one. If it's 1, we'll use the second one. If it's, yeah. So that makes this the index, which lines up with how we calculate it here. We just need to do some includes. What's the other one? Standard lib.h. And do I need anything else? Standard IO for printf. Alrighty. Implicit declaration CodeGen program. Yep, that's still okay. We have assert. One more include. Hey, it runs. Look at us. We no longer CodeGen, but it compiles and runs, so that's a good start. So we have these registers. And these registers, we're basically going to, I should just make register add take a null pointer and return a register, but I don't know. We'll see. In any case, we simply need an actual CodeGen program now. So we'll return an error. I think this is okay. CodeGen program. I don't think I need that. I'll just do parsing context. And what else do we need? The AST, the program. So we're gonna have to include the parser or do some funky forward declarations, but I don't want to do that. We'll include these in the here as well. That's in case. Elemental PQRS. Okay. That's really cool, Nolan. You're headed to like the remote countryside. I feel like all of America is remote countryside. Sadly. There's so much space. So allocate, deallocate. CodeGen program is here so that in main.c we have something to call. And yeah, we'll probably need an output format. We can do that. Enum, we'll just do output format. CodeGen output format. Why not? Nolan says, yeah, should be nice. I'll be gone for 1 week, but look forward to seeing the progression you make. Awesome. Yeah, hopefully we'll have made some progression and not cheat. We should have a lot of CodeGen done at that point. We should be on to like some serious type checking. CodeGen format default equals 0. CodeGen format x86 64. So should we have like a format and a calling convention, or should format include calling convention? You know what I mean? It's a one that's a little confusing. I don't think it matters right now though. We'll just do it like that. Copy that. Put it here. We'll just use the default actually. Why not? And then we need to actually have this used. Oh, I need enum here. Alrighty. We are going to CodeGen a program. But yeah, Nolan, I'm gonna miss you. It's gonna be weird. It'll be fun when you get back though to show you everything we've done. Whoops, whoops. Nearly. It's mad because I didn't name it. Hey, look, we did it. To do, not implemented, CodeGen program. Alrighty, we hit an error message. How about that? How about that? Alrighty. Register add. So we need to basically have this. Whoops. Let's do equals. Yeah, why not? And we'll just put it in the same format as that. So now we're basically just going to have error CodeGen program parse context node pointer program. We could also eventually move this stuff to a pointer, like a structure with function pointers, but we're not there yet. We are not there yet. So say if format equals CodeGen format default or format equals CodeGen format x86 blah blah blah, then call CodeGen program x86 64 mswin. Whoops, don't call it like that. Call it with the context in the program. And then just like that. Nolan says, I've been watching the DEF CON Live CTF events this morning. Very entertaining. I don't know what those are. What is that? Capture the flag? That sounds entertaining. We'll just return that. Good enough for me. Okay, and then we're just going to steal this little hunky-dory. Still working. It says to do not implemented, probably from here. Perfect. Everything is working as expected. So now we have to think about what we actually need to do. Also, this needs to return nothing if this happens. With descriptor of blah. Grammar to Parser Boy says, hello. Hello, Grammar, how's it going? Nolan answers, yeah, capture the flag. Basically, it's a 1 versus 1 head-to-head event where two people try to beat each other to exploit the binary first. That's really interesting. So it's like a coding event where people try and hack on a executable. That's very cool. Very, very cool. I'll have to check that out. You said that's running this morning. Or you probably said this morning as in earlier today. I don't know what your time zone is. So I may just be able to watch it on YouTube. But yeah, I'm very interested to hear how you are, Grammar to Parser Boy. I don't have auto hotkey on. 1 second. Caps lock 2. Okay, I'm gonna have to use everything. Caps. Oh boy. Well, that's going to take a little bit. I'll just use control for now. If you search live CTF on YouTube, you'll see the VODs. Awesome. Thank you, Nolan. Everything is still booting up. I just want caps lock to be control. So, yes. All right, we've done it. I can now have caps lock as control. It's amazing. Nolan says, "Hey, Grammar Do Parser Boy. Looks like you have a mostly EU following, Lens. It's true. Most of the watchers are European or Asian, which is, I think, really cool that people from another continent enjoy the content. You know what I mean? It's kind of fun to say too." All right, so now we should check out the parser because we need to add something to a node, and it's just going to be an int, I think. That's going to be a register descriptor, the result register. We'll just call it the result register. But this is a use during CodeGen store result register descriptor. How about that? Good Mallard says, "I'm also EU, the Dutchlands." Yep, Good Mallard is from the Netherlands. Grammar Du Parser Boy is from Germany. Nolan is from the EU. We got all sorts of EU going on in here. And when I stream earlier in the day, generally I get more people from Asia. Like, I believe Nevermind Who, he's from Asia. For Romania? Was he from Romania? That's in the EU. Yeah, I got a lot of EU following. I'd have to stream probably at like 3 a.m. to catch Asia more. Which I don't want to do. So now in a node, we store a result register descriptor, which we can get a name from. Nolan says England for me. Nice. So you were you were in the EU. Alrighty. So when we codegen a program, we're now gonna have to do codegen-y things. Right? Let's take a look at our notes. Nolan says, "Lol, still located in Europe." Did that whole Brexit thing happen? Is England different from the UK? That's probably a different thing, isn't it? I thought that was the same thing, but that could just be my ignorance. Done. That's a good idea. We'll do that. We'll create the label generator. So, and register stuff. Begin. Register stuff. Perfect. And then we're also going to have label stuff. And this will help our situation greatly, because we will not have to worry. Nolan says, yeah, the UK left the EU. England is one of the countries within the UK. England, Scotland, Wales, and maybe a little of Ireland, lol. Lamau. I see. So the United Kingdom is those countries altogether. That's interesting. It's amazing how hard it is to get information like that over here in America. Everything is so hidden and different. It's weird. It's like, you want to learn about other countries' history? No, no, no. Only your own. Because in America, it's like a circle of lies, right? Everybody lies to each other, and it's like a game of telephone. The lie keeps getting crazier and crazier, but we just keep believing it. And, here we are. Yeah, whatever. No, don't need parent. So, labels-wise, what are we gonna need? We're gonna need probably just label generate, right? And all we're gonna do is have, I think, a buffer. Label buffer size. 1024. Label buffer. Label buffer size. Label 0. And this will like reset the whole thing to 0. I don't think that's needed because we're going to be writing strings into it. And then we're going to need like could have a static here. Doesn't really matter. I'm just going to keep it here. Size t index. All right, so we're going to return label buffer plus label index. And then we just have to write strings into here, right? So label index plus equals, what is it, sn printf or something? So let's go look up what sn printf does, because we need to make sure that we don't do some screwy thing that we don't want to do. Oh, sorry, you can't see that. There you go, guys. Alrighty, alrighty. I've been streaming for just about 45 minutes. I would like to remind everybody that we are 5 followers away from getting that Twitch affiliate goodness, them custom emotes, them channel points, them VIP members. We're just 5 followers away, so if you would hit that follow button if you're enjoying. Oh, excuse me, this is a terrible ad. I would really appreciate that. So, yeah, thank you. And let's continue on. So snprintf, oh my Christ. No. snprintf takes in a buffer, the maximum number of bytes that will be written, that's good, the format string, and then the rest of the arguments. I think that's good. So we would like to write, this is generally how labels, internal labels, are generated by the compiler. And you do something like this. We'll just do, yeah, why not? Nah, we'll just do size t label count, which equals 0. And then we'll just have label count. You know what I mean? I think plus plus. Will that give us 0 the first time? We'll just do this. So this will increment label count every time. We now need the label buffer plus label index. We can just get the label, because we're going to need that twice. And then this will be label buffer size minus label index. Eternal Wild Fox says, "Good afternoon. How's it going, Eternal? You had some Discord messages I think I may have missed this morning. Nice, and some other people. Awesome. Yes. He says doing okay. That's good to hear, Eternal Wild Fox. We're making it through. We're making it through. Got a lot of EU. You updated your tree again. Now it has left number 1. Okay. Right number 1. Okay. and then a value with an plus operator. Yeah, that's pretty good. These are still very complicated to read, but I've figured it out at this point. So you have one node with one object in it. So this is probably like your top level program node, and then this is your singular expression, your zeroth expression. And your zeroth expression is this list of nodes. That's making sense. That's making sense. It's definitely doable. It's definitely doable. That's very good to hear. I saw that you were saying it's still confusing to evaluate. It always will be. Evaluation requires like thinking about the edges between nodes versus actual nodes, and you start getting a lot more things going on. But yeah, I really recommend joining the Discord. We have a lot of fun, and that link is down below as well. In any case, I'm glad you're here, Eternal Wild Fox, and I'm glad I could meet you on this good afternoon for yourself. I think that's fine. So we just want .l followed by this, and I think we just want that, right? So this will just give us a label. But do we want the, I think we just want the label by itself. We'll put the colon in ourselves, I guess. I don't know why we would do that. Let's just keep it like that. We can even do this. It really doesn't matter. So we can just emit this string into a file. And the idea is that is there a way to... Interesting. Basically, I want to allocate strings in this static buffer so that I don't have to heap allocate all these strings and free them. And I think the idea would be that the index, which sure starts at 0, would point to where the next string starts, and count refers to how many labels there have been, which is just for this here. So snprintf returns, if I'm not mistaken, snprintf returns the number of characters that were supposed to be written onto the buffer, irrespective of the value of n passed. That's good. So even if we don't write any bytes, it'll still pass the amount. It'll still return the amount that it should have written given this format string. So label index will always be updated correctly, which means label index doesn't mean the string will always be perfect. But we can say if label index is greater. Eternal Wild Fox says, I feel I am close to a solution. That's really awesome in your evaluator for your AST. That's really good to hear. I believe you have it. I believe you have it. It just takes, honestly, everything in compiler land takes about 3 days, and then you go, okay, I'm starting to get it now. So if the index is greater than the size or equal to it, then that means this failed. So we would like to say label index equals 0. Label count can stay the same, but return label generate. So if we attempt to write a label and we go over the end of the buffer, then we say, hey, don't increment count. Just give us a new label, but at the beginning of the buffer. So the idea is this will give us many labels before it's freed, so we can create like 8 labels in a row and use them all without really worrying about trampling on anything else. Eternal Wild Fox says, to be honest, it was a steep learning curve. Absolutely. There's no one that's gonna like hold your hand through it because everything is so complicated that no, you'd have to have a one-on-one teacher for like 8 days to be able to have like a beginning of knowledge And then you would just learn the way that they did it. You wouldn't, you know what I mean? So it's cool to see everyone learn their own way and turn compiler, uh, the problem of a compiler into their own problem and into their own puzzle in language. Eternal Wild Fox says, pretty sure I can learn it. Absolutely. I think everyone can, but I think some people definitely have an easier time, like you, because you get programs, like you wrote an assembler in like 2 days, an assembler and a disassembler. I was like, that's impressive. We should test this label generate and just make sure it works. Also, we shouldn't implement it in the header file, as it turns out. Yep, we're just going to need that. Labels are simple. All right, let's do some testing. So we want char pointer label 1. That's probably going to be literally labeled 0, but I just want to make sure I can create multiple labels in a row and not worry about what's going on. Why not? Can I put numbers here? I should have just put numbers here. I don't know why I put the words. Unless I can't put numbers, then that'd be pretty funny. Grammar to Parser Boy says, Eternal Wild Fox, next time it will be a lot easier. And Eternal Wild Fox responds with, yeah, indeed, thanks, Grammar to Parser Boy. He is correct. It gets easier as you go. Because you're like, oh yeah, I've done this before, I kind of remember, and then you don't have to do such an extensive detour every time. It's really cool. Is there 6 here? 1, 2, 3, 4, 5, 6. Ooh, did you hear my stomach? Okay, this is interesting. We're not including the null terminator. That's a simple fix. That's better. I guess each, we don't need the new line even. Because of, yeah. So in here we could just like, there we go. Yeah, just like that. The labels. Look at us. Eternal Wild Fox says, I write simple lexer and parser now much faster and easier, so you two are making valid points. Yeah. As time goes on, it always gets easier. All right, we have a way to generate labels. Ain't that a thing? So now we don't have to worry about like our previous random thing. We can generate labels in this way and not worry about it because numbers are allowed within labels. Wonderful. And I like how that doesn't require any heap allocation, and we have all these different strings that we're using. And we can get multiple in a row. It's pretty good. I'm happy with that. That's the wrong place, which is why I'm confused. So now that we can generate labels, we can allocate and create registers with names and descriptors. We have a CodeGen output format. This is starting to come along much better than before. Our API is going to make this a lot simpler to build. Then, that's correct, we also need CodeGen symbol, which I actually wrote. So if we actually look at the tree, you can see that there's some issues. Namely, when we do a variable reassignment, we have a symbol A. And if you know anything about assembly, you will know that you can't like write to a symbol A. You can't assign A equals to something. So this is gonna have to be converted into a memory address. So we're gonna have to have a symbol to memory address converter. That way we can kind of just get a string that will calculate the memory address for us from a symbol, if that makes sense. And to do that, it's going to be a little complicated, but it's going to be okay. And we're going to try it out. So the idea would be that I'm also thinking about removing global variable declarations from the program AST, because it's not clear to me that we need them. The only reason we would need them is if they don't have a none. So in which case we should just treat it as a reassignment in the AST, if that makes sense. So I think the variable declaration node will only be stored globally. Like it'll work in functions and we'll do stack allocations, but global variable declarations will be converted into reassignments with the expression or just removed, because we are going to use the parsing context to generate all the global functions and stuff like that, variables. In any case, that seems like something valid that we need to do. So we need the way to convert, oh Christ, I think this is a little overcomplicated. So let's try and write it from scratch. And we'll just have, what is this? This is CodeGen symbol. I'm gonna call it symbol to address, right? Let's do that. And we're basically, we'll only do one at a time, or we could do the same trick we did before, which I think is worth it. So let's do this and put this next to label generate so we can kind of work off of it, if that makes sense. I'm just also gonna remove this. It's kind of clear that the one function for labels is for labels. I thought it was going to get a little more complicated. Symbol, yeah, why not? We'll just do symbol. Symbol buffer size. All right, and the idea would be to do the same thing, calculate our symbol address, which is going to be symbol buffer, which is really just a pointer, and symbol index. Look at us. Then we can say symbol index plus equals sn printf, and this is actually going to be a little more complicated than I thought it would be, I believe. So this is going to have to be per implementation or something, I think, because this syntax will be different based on what we're using. So this may actually go in here like that. I think that's how that'll work. And we'll just have, I guess we don't need to call this from external. These can be internal functions, like static functions. And yes, I know, you have things to do. Then we need n, which is going to be symbol buffer size minus symbol index, the format, and then the format requires a string. So let's think about what we have here. We are trying to convert a symbol into an address. So we have some symbol, and we would like to rip address it. This would be a global symbol, a global variable access, right? So we're going to call that what it is, global variable access. I think that's fine. And then we're going to have to do the same little ditty here to skip the symbol null terminator. Alrighty. And the actual symbol here, we're going to have to do local variable access. Why not? The symbol here will actually be the symbol that we are passed. Like that. We can't call that symbol, so we're going to call this symbol string instead. A little complicated because the line's a little long. That's a little better. So we're printing into the symbol string this many bytes with this format. Oh, I need to do that. So we need a single percentage sign, but because a percentage sign means a format character, to actually emit, have snprintf emit a single percentage sign, you need two. So this will be percentage rip in parentheses. And the symbol will mean that we have a rip addressed symbol for relocatable code. Wonderful. So now the idea with that, I guess, is we're going to have a node. I guess this is where we should have the file stuff. So we're going to open a file. Should we already open a file in here? That's probably what we should do, right? That would be, I think, the way to go. Then we just pass the file. Like that. I think that's fine. And we'll call it code just to be consistent. So open file or writing. But we just return this. So we would kind of be responsible for closing the file. I don't know why I just typed status. Who am I? We're just gonna call it code. Right? Do the same thing we did before. Write binary into it. I think that's worth it. Oh, we'll write text into it. Why not, right? I don't think it really matters in this case. So, Mr. Mugame, how's it going? It's been so long. You're back from vacation. It's so good to see you again. How are you doing? How was your vacation? Was it relaxing? Sometimes vacations can be rough. We're getting better. Alrighty, so now into this file, I would like to have CodeGen program, CodeGen expression. And we're going to probably have a char pointer? I don't know. Should we just return a string to write into the file? Or should we just write into the file ourselves? I feel like we should just write into the file. That way we don't have to deal with it. Yeah. Mr. Mugame says, I'm good. Got one heck of a sunburn, but vacation was great. Nice. Oh, sunburns can be so rough. I feel for you. Code pointer expression. So, okay. What expression should we try to CodeGen? We could do a variable declaration, right? In which case we would have to like we're also getting into some other territory here. So let's look back at our notes, make sure we're not missing something. Okay. Yes, it is. Dynamic register structure, done. Label generator. Done, I fixed it. Yes, simple CodeGen steps. Generate children in order. Okay. So, technically, no matter what it is, we should generate the children first. Right? Oh Christ, sorry about my stomach. So, Mr. Mugume says, how far is the compiler? In Eternal says, he did lambda functions yesterday. Yes, we parsed functions and function calls. So if you take a look at our compiler, here's the output from it. And you can see that if we take a look at the actual example program, it's pretty good. So we have A as an integer declared to be 69 on the global program scope. We have a reassignment of A to 420. We have a declaration of B, which is an integer. And we have a reassignment of B to 42. We have a defun foo with two arguments, C, which is an integer, and B, which is an integer. So that's a function, right? It returns an integer, and it has a body of a bunch of reassignments to C, right, as you can see. Eternal Wild Fox asks, does your compiler make object files to be linked lens? No, not yet, at least. That's the job of an assembler. We're generating assembly from our compiler. And the assembly will be compiled into machine code, native machine code. We're going to use the open source and free GNU as. So you can use GNU as, the GNU assembler, to assemble our assembly files, and then we're going to link them together with LD. But yes, our compiler does eventually, in the chain, generate object files that are able to be linked with other things. Mr. Mugume says, it feels so weird using a keyboard. I type like my grandma. Lamau, you got those vacation hands. You're still not used to it. Oh yeah, and then you asked how far is the compiler. We also have function calls, so we can call the symbol foo with two arguments, and we can have technically, I think, any arguments right now. Not doing much type checking. Yeah. But, you know, that's where we're at. Yay. In any case, we are currently, we deleted the entire CodeGen and have started it from scratch. So yeah, that's where we're at. So we have a program which is a list of expressions that we should generate, right? But not all of them should be generated. So we are going to switch on the type. I don't know why I got rid of that. I think I got scared. Default, break, case, node type. Let's think about so a function would mean that we're doing a lambda if we're not on the top level scope. So thinking about a variable reassignment. We have to know if we're in the global scope or not. And if we're not in the global scope, we have to access the CodeGen context. Okay, so we haven't done the CodeGen context. That's right. Eternal Wild Fox says, idea for optimizing your compiler based on file change. If the file is not changed, use the object file. I believe most modern compilers do that. Yeah, that's called incremental compilation. That's definitely something we're going to do, but not something we're working on right now. But that's a great idea. Same thing with just not having to parse and then mainly you just don't want to read a file and parse it. That's really the longest part, is reading it, lexing, and parsing. CodeGen is bad enough, but it's not too bad. It's kind of just emitting bytes into a file based on data that already exists. The little context you do have is not too bad. So it's going to contain a context pointer, which is going to be the parent. And then we're going to have, what are, excuse me, what are we going to have? We are going to have a list. We just do an environment like we normally do. I don't see why we don't just do an environment like we normally do. We should probably include it. I cannot type. I think that's fine. So with this CodeGen context, I would like locals to contain a symbol name, a variable name, which is mapped to the integer stack offset, right? Yeah. Okay, okay. Eternal Wild Fox says, I'm going to write a simple lexer parser and interpreter which can simply calculate number plus number structures, just to get used to writing a lexer parser and defining rules. That's a great idea. Limiting the input syntax is really the most helpful, right? Because then you can create a program that can do the right thing every time and it works. And you're like, okay, this can't be wrong because it does work, right? You have a little bit of solace in that. And then you can move up from there like, oh, I see how I could extend this structure. Yes, I went over my head for allowing parentheses also. Parentheses aren't bad. You just reset the, you basically just need a precedence stack and push your current precedence, set it back to 0 and parse the next expression until you get to the end of the parenthesis. Then you reset, pop off the stack, your precedent. It's all doable. That's a prat parser, but there's lots of ways you can do it. But you're right, it is a lot of extra complications that it adds. So with this CodeGen context, where are we actually going to need that? I think we're going to create it, similar to how parsing context works. So we're going to call this, we're just going to call it CTX. Well, no, we're going to have CG underscore CTX. Yeah, why not? Why not? Why not? Okay, okay. So with this context, I think we're going to have to like have a helper that creates a new CodeGen context. So let's just do that. That way we can do this a little bit differently. All right, and this I would like to write, excuse me. I need to keep track of the pointer. And we're just going to calicate one of those. Calicate, malocate. Give me your memory. Okay, okay, okay. Return CGCTX. And we should say parent equals. Probably have that be a thing. Parent. Null. Wonderful. I guess we should do this here then. Locals equals. I guess I have to do that in any case. Locals equals environment create. Okay, so this is going to be different. And we're going to say a parent else. Just to be clear. So if not parent, we're going to use null. But if parent exists, we can dereference it and use its locals as a parent for this environment. Does that seem logical? I don't think that seems logical. Let's not do that. Let's just create, each one has a new locals environment. Why not? Alrighty. With these contexts, we should work on, do we have environment free, by the way? We don't have environment free. That's kind of unfortunate. We're going to add that to the to-do somewhere. Environment free. Good enough for me. To-do, environment free. Mr. Mugame asks, how did you implement an AST in C? Let's check it out. I took a lot of inspiration from how Lisp works, if you're familiar with that. So we have a type, just an integer type, which tells us how to treat the node within the AST. And the type is generally one of these enums, but it may be a user-defined type eventually. So we have an enum node type, and most of these types are symbol, function call, variable declaration, etc. Different things within a function, within an AST. So that's the type. And then we have a union, which is the value. And the value can actually be any of these, any one. So it could be an integer or a symbol. And the idea is that if the type is an integer, then you know value contains a valid integer and stuff like that. And then it has a pointer for its first child, and then a pointer for its parent's next child, if that makes sense. So if we take a look at some basic node with like a left and a right, then it would have children, right, which is this symbol here. It would have left and then right. And this right here would be the children pointer. And then that right there, that arrow, right? That would be the next child of left, if that makes sense. So children would point to left from node, left would point to right from next child. So you can iterate all the children. Yeah, okay, with a union, that makes sense. Nice. PushKeyRDX says, I use something similar to the shunting yard algorithm that parses precedence by repacking left-right based on next token. Nice. I have a video open in my browser by, who is it? I don't have it open anymore, rip. Anyways, I had like a 2-hour video loaded on shunting yard the other day. I just haven't watched it yet. But yeah, we just use a union and some basic pointer magic. And then this result register we're going to use in CodeGen for the expression result register on that edge. It's the edge connecting it to its parent. Alrighty. But yeah, any more questions, let me know. So I just knocked my shelf. So we now would CodeGen a program. So this program, I would like to loop over expressions within it. And then I can say while expression equals expression next child. So this will loop over the AST. PushQRDX says, it's vaguely similar to it, but my version, which I didn't find a name for, is way simpler and does the job. That's the way to do it. You should write a book about it and make like $1 million. And then we just want to, into this file, with this context, CodeGen that expression. I don't think that's too insane. Right? Yeah, I don't think that's too insane at all. And we could say for each child CodeGen expression, like do we want to go that far? While true, echo, input equals read line. Interpreter equals new interpreter input, echo answer, interpreter expression, /n/r. It already works, lol. There you go. You did it. Eternal Wild Fox has written a simple calculator. It's pretty cool. Pretty cool, pretty cool. So the idea is if the expression is a variable reassignment and we're at the global level. How do we know we're at the global level? Well, our CodeGen context parent would be, I think I can just put this on a new line. It might not be the worst. Okay, we're doing new line on new line. Splitting it up. That's much better, I think. So CodeGen expression, x86-64 mswin. We need a CodeGen context. CodeGen context, CD context. CodeGen program, yes. CodeGen context, yes. Yes. Okay. We've done it. Grammar to parser voice says next step variables? That's so complicated. That's such a big leap. So pass those through. And if CG context parent printf, I guess I can just error prep, right? Error to do. CodeGen expression x86 64 mswin, and we're gonna say, hey, we can't do that. We're basically gonna say cannot do local variable CodeGen yet. Sorry. That's a real error message right there. That's good. Else, return that error too. Doesn't matter, but we'll do it. So we'll just break here. Eternal Wild Fox says, lol, grammar do parser boy. Let me first get the math expression engine working without variables. Exactly. Yeah, just get like operator precedence down, where you can get pluses going above multiplications in the tree, and then you're good. So if it has a parent, then that's a local variable. But if the CodeGen context does not have a parent, then we pretty much just have to say symbol to address, right? And what symbol? So a variable reassignment, we need to take a look at our documentation on. It has the variable identifier as its first child. So children will equal the variable identifier. This will equal a string pointer, right? So this string pointer, we would like to is there like a fprintf? There is. Fprintf stream format blah. We just want to write, I mean, we could just do fwrite as well, but then we have to like know the size of the string and shit. This is easier. Hey, not yes John, how's it going? It's so good to see you. Thank you for chatting. How are you doing? Not yes John says, hey Lens, did you know that it takes 4 kilograms a meter per second to queek a baby? But another reminder is that you're incredible. All right, bye for now. Thank you, John. Are you a real person? What does queek a baby mean? Queef. Okay. Lamau, I have to allow that. Yes, I am. That's good to hear, not yes, John. That's good to hear. I was worried about it. Kind of looked like an odd sentence. I was like, what is that? But now I know it's an odd sentence only a human could have come up with. So using the symbol to get the address, we will write the entire line. Not Yes John says, I didn't code something to do this occasionally. I see. Push QRDX is not real, John. Lamau. Yeah, that's his alt. Oh, Christ. Okay, let's just see what this does. Hey, look. It's working. Now, before we CodeGen the program, we're going to have to do that thing we did. We should probably make a commit to very soon. Where's that CodeGen thing we did? Yes, this. I like that. Oh, Christ. Okay, and I didn't grab the closing one. Does that help? You don't have CodeGen function. We can steal it. No, we don't. I don't think we need that. Well, we're probably going to need CodeGen function for lambdas as well. So this is absolutely doable. We're going to take a look at what CodeGen function was. Because if it was awful, we're not going to use it. But if it wasn't too bad, you win some, you lose some, right? Yes, generate the global functions. I would like that. CodeGen expression. Symbol buffers. CodeGen program still. Here it is. Can I just steal this? Do I get it all the way to the end? Hopefully. Let's take a look at what it looks like. Christ. Okay, just gonna do the same thing again, and okay, so we need a close. Probably gotta be a return okay or something. Get rid of all these extra spaces. So we generated a jump after. Push RBP, move RSP, sub, blah, blah, blah. Function header, function footer, nested function, execution, jump, label. That's right. And name is something past. Not yes, John says not fake John. Lamau. That's amazing. Thank you so much, John. I really appreciate you. Hopefully you're doing well as well. And don't feel like you need to stay for long. I know you said bye for now. In any case, I've been streaming an hour and a half at this point. I would like to thank everybody for watching. I'm not ending the stream, just doing a little bit of an ad read. Hashtag sponsor. Not really, though. I don't have sponsors. Down below, if you would hit that donate button, it would greatly help me out. If you would drop a few dollars into my PayPal. It is one of my only sources of income, so I'd greatly appreciate any and all donations. If you leave a message, I'll read it on stream, and if you leave your username, I'll say who did it and how much you gave. So, yeah, thank you. If you left a donation and you didn't get attributed, then go ahead and send me a message, and an angry message, right? A heavily worded letter and say, hey, say my thing, right? Unless it's too offensive, in which case I won't say it. But, in any case, I would greatly appreciate any and all donations. Be sure to hit that follow button down below. 5 more follows and we unlock channel points, we unlock VIP members, we unlock custom channel emotes. We got so much just with 5 more followers. So if we could get that happening, that would be amazing. That would be amazing. And also I get Twitch affiliate. So you guys could subscribe and you guys could also, again, yeah, get channel points, cheer bits, everything. The fun stuff. The fun part of Twitch. Okay, so what is this? Why do I have parameter here? What? Quit. So we basically just CodeGen expression list. I see. So we're gonna kind of need to redo this whole thing, but I'm just gonna write out what we need. So this should be jump after, and this will be like function symbol, function label, not, right? And then that's that. Then we have function begin memory symbol. So this is the label. Function beginning label, right? So this will be like function label. It's like that. Then we have the function header, which is going to be push RBP. So it's not going to change. Yep, just give me you. And give me you. So this makes stack space and updates the base pointer after saving it. It also keeps the stack 16 byte aligned in case we make any calls. I think that's what the x86-64 ABI says we must do. In any case, context equals parse context create. So for the function body, the idea is that this should be CodeGen context create, right? That would be the idea. And then we have CodeGen context, CG context. How about that? That looks pretty good. Alrighty. Probably gonna have to move context create up a bit. That's not a big deal. Yes, so the idea is that we have a singular expression, and this is going to be an entire function. Yes, and in the middle, so I can probably convert these rather quickly. All right, we kind of have planned out what this needs to do, but let's think about what this needs to do specifically. So when we could just say pointer expression equals that's a long one. Okay, so now we have this generating an error. Is that not what that returns? Oh, we don't have lists. Good enough for me. So we need file code first, then CG context. Already. there's our error handling. So now for a function, we generate all of the function body expressions and then get rid of our context. That seems valid. In this local context, we just need to store the integer offsets of the parameters, right? So at some point in here, right, we should say to do store base pointer offset, integer offset within locals environment. We're going to environment set into the CodeGen context locals environment using each. Okay, here's why I needed parameter, I bet. So I think it's function children would be the first parameter. So function parameter, so function children. Yep, and then each one contains a parameter with 2 children, yes. So function children, that's the first parameter. And the parameter will have a child of the name symbol in the left side. So if we want to access parameter children, let's just make sure of that. Let's print node parameter children, right? We'll wait on that one. Okay, lots of errors. That's wonderful. It says CodeGen function passing argument 1 is wrong. Does it go this way? It passes CodeGen context first, is what it's saying. Hey, look, it worked. It worked. And we get the symbol C. Yep, that's perfect because in our example, in our function, that's our first parameter name. Look at us. Node. Okay, so this symbol C, parameter name, so this would be parameter children. And then parameter type, I don't think we're going to need the type right now. So locals, we may need the type. We'll think about it. Okay, so with this environment, we would like to set the parameter name. So the environment set will steal ID from the child. That'd kind of be like a dependency, circular dependency. So we're actually going to say parameter name is function children value symbol. Well, we'll keep it like this actually, and then we'll say while parameter set all of the parameter symbols to all of the stack offsets. Okay, so we need some integer here with stack offset. So let's just assume each argument is 8 bytes for now. Why not? We can always get more efficient later, right? Based on the type or whatever, the type size. So we're going to say if each one is 8 bytes, we have param count equals 0. Then this should be param count times 8. And this is actually going to be negative because how it's going to work is in assembly, we're going to end up with like a function and then after foo, right? This is kind of our style. But we're going to end up with a function which pushes the base pointer and pops it. And push will push it onto the stack, and pop it will pop it off of the stack. So our base pointer will be restored to whatever it was before. Then we say the base pointer set to the stack pointer during the function execution. So to do that, that means our base pointer is actually this stack pointer, which means just above it is the base pointer. And because this is a push RBP, this is 64-bit and 8 bytes. So essentially, this address, this stack pointer address, should point to the bottom of RBP, right? Like the end of RBP. So -8 on the stack should read the stack pointer, or the base pointer, excuse me. Because this is our stack address. And we just pushed this, so -8 and dereference that would be this from the stack pointer, or the base pointer. Because those are now the same. So param count times 8, and it'll start with 1. And we'll say start at 1 to make space for RBP. Pushed RBP in function header. Sure. Okay, so we may even have to start at 2 or something, I don't know. In any case, we now count the parameters. We print each one, which we don't need to do. You don't really need that as a separate thing. So we bind parameter name to integer stack offset, well, base pointer offset. So the parameter then has in the local environment set to the node integer or whatever. And we should do this before we do that. So we create a new context, bind our parameters into the new context locals. We then generate our expressions after doing our funky business, and then we read our context. I think that's not too insane. All right. So let's have this. I'm just going to convert into a single string. Right? I don't think there's any reason it shouldn't be. It doesn't need to be split up at all. Then we can just write this with fprintf or something. We could even split it up a little helpful for us with our eyes. But it can all be one string, I believe. And let's just do that. I think that's better. And then we can print into the code function footer, and that's a string. I think that's much cleaner than what we had going on before with all the lines and stuff. We may change our minds, but I think this is reasonable. Move the stack pointer into the base pointer, and then make some space on the stack. Sub 32 from RSP. Did that a little backwards. Look at us. So now we push, move, stack space, print that. So we're still going to need the actual function label, which I think we're just taking from here, because a function won't necessarily have a label, so we'll either generate a label or we will. Yeah, that makes sense. Alrighty. So using the function label, we need to do some things here. Let's say print into code, jump after blah. And that's a whole line. And the format is going to be the function label, just the name. Same here, that's going to be pretty simple. Just a label. Function beginning label. Nested function execution protection. Looks pretty good to me. So we jump after, in which case we have to go do that thing. Code, we would like to print a string after with a label of our name. I don't think that's too insane. So we bind all our parameters, negative on the stack where they supposedly should be, right? Our local parameters. So that means our function call wouldn't actually access RCX and stuff, it would access the stack. We can think about this, So we should say to do. So in the locals environment, maybe we should have a register name also be a possibility. Let's think about that. Or a register descriptor, but then we'd have to have they're both integers, which is a little tough. Because the issue I'm thinking about is that when we call, I kind of want to use the same, the C calling convention, which means that we don't actually push all the parameters. They get moved into registers if they can. RCX and RDX and stuff. If that makes sense at all. So the idea would be that we need to have some way that a parameter, when we get it, it wouldn't access the stack, it would access a register, right? So I'm just going to add to do. It's going to be below the fix me. Good enough for me though. So bind parameter to integer base pointer offset. Assume each argument was 8 bytes. For now, to do. This currently doesn't allow for passing arguments in registers, which is slow, which is much faster, I should say. Yeah, a little bit of an issue, but not too bad. So for each function, we generate the function. Let's just try running this thing. Did I forget something? Everything here looks good. It's running forever, though. How did we run forever? Which while loop are we stuck in? This one. Look at us. There we go. Now if we take a look at code.s, look at us. This is a little confusing. Considering. So all we do is CodeGen program. CodeGen program, all it does is generate expressions. So how do we generate expressions? So that's where this is coming from. Let's put a new line on that. Right? Nearly. Sub 32. Okay, there needs to be a new line at the end of these. That's good to know. Hey, that's looking better. If we format it, you can see that this function, we have push, move, sub, but then we didn't have add. This didn't happen, did it? So it says CodeGen program x86 ms win, which means this. And all we should be generating for the actual program is these two reassignments. We should spit out symbol B and stuff, accesses. Which is these. It's still confusing why we're running into an error when it seems like we shouldn't. So let's just printf here or something. See, we never printed here, which is a little worrying. So let's make sure that we print this error or whatever. Okay, and it says, cannot do local variable CodeGen yet, sorry. Error to do. That makes sense. There are reassignments that we are trying to CodeGen in. Yeah, that makes sense. So let's just try and ignore it, skip it. Then we get here. Okay, this looks better. Yes. After. With a new line. So the idea yes, thank you, that's better. So now the idea is if we encounter this, like execution-wise, we'll jump right over and continue execution. But when we call, we have our little function here. And look, we push move sub, add pop ret. That's perfect. This is perfect. So now the idea would just be to, you know, start to actually generate expressions. So let's do that. A reassignment is not going to be just a nothing like this. We're going to have a move address in the reassignment, and we would like to move, well, something into, whoops, what happened? I don't even know what just happened. Okay. So we would like to move some register, right? And I think we would like the result register of the assignment expression. I think that's logical. Okay, that's not gonna work. Do that for now. So the idea is this reassignment, right? We would like the result of this expression to be in some register. But what register, you ask, right? An allocated register. So let's try and set up in CodeGen program x86 our register. Sure. Is that how I did that? And then we need a name. So let's use a scratch register. I believe R10, but let's look up scratch registers. So scratch registers in x86-64 in Microsoft ideally. That's not helpful. Okay, so what am I looking for? Looking for which registers are, yeah. So across function calls, perfect. So RAX is volatile, RCX, RDX, R8, R9, those are arguments, so they're not quite volatile in the same way. But R10, R11, volatile. Preserved as needed by caller, used in syscall sysret instructions. So must be preserved by callee. are all these. So all these volatile registers are ones we can use, right? These are floating point. So let's use racks, R10 and R11. That seems reasonable. And then I can just say register add to R. Okay, so these registers can be used for results of expressions, racks. These are integer arguments, so those could be used sometimes. We'll have to think about that. And these are non-volatile and must be preserved. So Microsoft really does not leave you with a lot to go on past the arguments, do they? They're like, yeah, you have racks R10 and R11. That's it. Not Yes John says, on Omegle looking for people to talk to, but you're doing great, man. Keep it up. Thank you, John. Yeah, I'm doing something. So we have this register set, and with these registers, hey, I got a follow. Night Nassar followed. Thank you so much, Night Nassar. We got a lurk. Can we get a lurk in the chat? Get that emote. But Night Nassar, thank you so much for following. We are one step closer to becoming a Twitch affiliate. Yes. So with these registers, we're going to need to use them. Right? So in a reassignment expression, we're going to need registers. This is terrible. This is getting very complicated and bad. We can't call it that. Call it R. Right? And then we have to say the assignment expression is the second child. Like that. So this is the actual expression. So we would like to CodeGen this expression first. Right? x86, yeah, into code with registers, CodeGen context, yeah, and expression, that. Error equals, if error.type, return error. Okay, so this CodeGen expression will return the child. So then the idea is that we should set the expression's result register. So this will be register name of R on expression children next child result register. So whatever this expression gets allocated into, or CodeGen'd into, wherever the answer is. I don't know what the lurky mode is. Oh, rip. Ooh, I don't either. Let me look it up. Let me look it up. I don't know. I don't know. Is there a list? Can you search Twitch emotes? Is that possible? Interesting. Rip. I can't find it either. That's really interesting. Maybe it's from a like Franker TTV or something. We'll have to find it. I'll have to figure out what it is. Nolan, just for you. We'll figure out what it is. In any case, so if we CodeGen this expression, we should get the result register into here. And then we move into this memory address the result register. So this doesn't exactly handle like structure assignment, but this handles most assignments. So let's see what that looks like. Perfect, it breaks. So we now need registers. Not. So we don't have register here. Ain't that wonderful? R. E. Go ahead and do it again. R. The errors will slowly stop. There we go. And what did we generate? Nothing. No, just kidding. We generated move racks A rip, move racks B rip. So result register is always 0, is what that means. Because we're not actually codegenning this expression properly. So codegenning an integer we should just place that integer into an allocated result register. So we gotta say register descriptor. Well, I guess we could just say that expression result register equals register allocate from R. So now we have our result register set for here. And then after we use it, I think we can register deallocate this crazy thing right here. That will work. Because then we can use that register again after we've used it for this assignment. So we get this register, and then we have to move the value into the result register. So the register name in R of this register. And then this is not quite what we need. We just need expression value.integer. Do we not? Look at this, look at this. Hey look, we did something very wrong. Oh, I think I know what it was. So after printing, yep, then we're alrighty. Look at us. Look at us. So these variable reassignments are now properly being generated. We have an integer 420 moving into racks, and then racks moving into A. Obviously, this can be simplified and optimized. These are too many instructions, right? But it doesn't matter. Optimization can be done later. For now, we get working programs. I still can't believe I don't know what the lurk emote is. vme used it all the time. Which emote search? Is there like a search for all the emotes? Can I search the lurk? I don't see it. It's incredible. Okie dokie. So it probably just doesn't have lurk in the name, but it just says lurk. Wonder what it says. The actual name of it. We just have to search through all of them. Or it could be a subscriber emote to another channel, I guess. vme, I think, pops it in all the time. I don't know. We'll have to ask vme next time he's in here. vme trolling us with premium emotes. He really do be doing that. He really do be. So this is good. Yeah, this is fine. Well, we're still trying to do that. So the idea would be to now think about how to actually get these things working together. So at the top of the program, we're going to need some things. Like, also maybe CodeGen program shouldn't open the file. Maybe CodeGen program, the implementation should open the file. That way it can name it. I don't know. We'll see. It doesn't matter for now. Basically, we just have to, at the top of the file, ensure that we generate global functions and generate global variables as well. So we're going to have what? So we want to write .text after this. Something like that. Why are you mad? Redefinition of function. Oh yeah, I'm working on that. This will be section.data. And this will be variables. We'll just call it var. Why not? So the variables, this would be the type. Right? So we have type and value. So we would like to CodeGen a function. No. We would like to printf into code the, first of all, var id value symbol. And then we need to allocate space based on the types. We need to look up the type in the actual types environment of the parsing context. So we're going to say air equals, and well, I think we do parse get, and we can do environment get to the parsing context. And we're looking for types. We're looking for this type, and I wonder if we can write into the same one. Maybe not, so we'll just do type info equals node allocate or whatever. Yeah, that's fine. And we can say free type info. This is an integer, so all I have to do is say if this, then there's else error. So we have error prep error with an error generic. Say could not get type info types environment. And we'll print out the type that we're dealing with. I think that's worth it. Okay. We'll just kind of create that type of thing. So now with type info, we can get the integer from what? Let's print out this node so I know what the hell to put here. We get none. Well, that's not ideal. And type says null. Also not ideal. So I did something wrong. Ah, yeah, look at that. That would be a big deal. That's better. So we have an integer type. So the top level node contains the type integer, whereas this is always an integer and contains the size. So type info children value symbol. And that will be the size. Oh, it's not symbol. Oh, what? And don't have to print that out. And look at us. We now don't create new lines like dummies. Okay, look at us. Now we allocate B and A. And we even, I think this may even be doable. Right? Code.s into code.o. Shell command succeeded. We made an object file, boys. We did it. Now we can link that object file into an executable, hopefully. Shell command succeeded. Hey, and then if we run it, failed with code 29. I don't know, that's not great. It's probably just because we have no exit here, so it doesn't know what to do. It just runs off the end. Lol. It makes sense though. We still need to generate like the main function effectively. So if we think about that, I'm also going to do this. Just going to help myself out a little bit here. Put the header above the footer like a sane person. Go use these new names. And then I can just use them here as well. So section.text. What do I want after that? So after section.text, I would like to have, let's see, main and global main. And as far as this goes, it'd be great if I could do nothing. I think that's fine. Not too bad. So write section.text global main main. And then at the end, we just have to write, what, ret or something? Also return OK. I don't think that's too insane. We should do our little function header though. So that'll be our that. Right, function header contains, yes, just that and that. They end with new lines, so I don't have to worry about that. And yes, now do the same thing for the footer. Do not implemented CodeGen program. It's interesting. Okie dokie. Still looking good on that AST. And this isn't looking too bad. We could move the global function definitions before everything else. And then let's do that. Boink, boink. Hey, look, that's much better. Okay, So now we have main, does the things. This doesn't look too bad. At the end of main, before the footer, let's move 0 into racks for our return value from main. Yep. New lines, always a thing. Looks good to me. Now if we try a little dance. Hey look, it worked. We did it. And if we put 69 here, we should see that 69 come through, baby. Shine that 69 through to me. Show me the light. Hey, it shows me the light. 69. Hey. Hey. Look at this. Shell command failed with code 69 and no output. That's beautiful. Nolan gives PogChamp. PogChamp. Hell yeah. Eternal Wild Fox says nice work. Thank you. Thank you. This is it's beginning to actually not be terrible. It's pretty nice. So I feel like I should also have a functions local, like local functions. It should be a thing. That doesn't sound too insane. So now we generate global variables, generate global functions. We generate the body of the main program. And then we emit a few different expressions. We do reassignments and integers. That's it. So what we could do is return the string, and then that would allow us to change it based on what it is, but that's kind of complicated. I don't think we need to worry about that right now. We could also just have custom checks here. So what I'm describing here is, so we have basically, we move this number into racks, and then we move racks into this address, but we can just move this number into an address if I remember correctly. Move has an immediate and memory address operand. So it seems like it should work if we just moved LLD into our final result register, which is what we do, but we do it through racks, if that makes sense. And the idea would be that, well, I guess all we'd have to do is say, if the result of this expression is an integer, not if the result of this expression is an integer, if this expression is an integer, right? We're doing a little bit of compiler optimization, so bear with me. Type equals no type int. Else. We're just going to call it results. Already optimizations. It's true. It should be simple, because dealing with integers, literally, we don't need to do this whole indirection bit. So we can just say result equals. We're going to have to... Premature optimizations are the root of all evil. It's true, but this is a simple one. Lamau, Eternal Wild Fox. You could be right. This could be the end of us. But I would just like to say result equals like $ plus LLD, right? And then effectively, we're just gonna have to say free this string, right? We'll just handle these entirely separately, because we don't need to deallocate the result register in this case either. So we're going to say result equals allocate, and this is kind of be a malloc. And I think we're just going to take like 40 bytes. We'll do 64 just to keep it like 2 to the something. And the reason I'm doing this is so that I can write an integer into it. So result, I would like to write percentage LLD followed by a dollar. And I would like to just use the child's value directly. Value.integer. So if it's an integer, just use the integer. And then in this case, so we have results now. So now moving dollar number into result, and then we don't need to deallocate, we need to free result. Then we should say if result, not result, like memory allocation error or whatever. I don't have error memory yet. That's bad. Could not allocate integer result string buffer. Sad face. Because that's a sad day. We'll just go error generic for now then. I don't really want to deal with that. Hey, look! Our optimization, it worked. It worked. So now instead of moving from racks into this memory address, we can just move directly the integer. And if we, what's it say? Using default for move. I see, so it doesn't know how big this number is. Can we do like that? Does that work? Also, I just screwed this up, but does that work? How do we do memory size operands? I guess we do it with the suffix. So if it's an integer, it'll always be a move q because integers are 8 bytes. There we go. Link and run. Hey, it works. It still works. Beautiful stuff. Beautiful stuff. And we could even move. So now, yeah, that's a very simple optimization. Very simple optimization to handle an integer node assignment. And that will, honestly, it'll speed up things a lot, not having to do an entire literal load and then like a register transfer. We can just do a literal into a memory address, and that's this opcode is much more efficient in that sense. Look at this. This is actually working. Isn't that beautiful? Ain't that beautiful? All right. And now we could even do math. We could start implementing math nodes and it would work. Because, yeah. Eternal Wild Fox says, you know what would be funny if I'm a bit further in compiler programming to program a compiler in PHP. Absolutely, it's doable. It'd probably be a lot easier too with like string operations. You know what I mean? But absolutely, that's a good idea. Because a compiler and an interpreter are just different different operations you can do on an AST, right? Eternal Wild Fox says, yeah, you don't have to malloc. Are you saying do this? I think I have to malloc. Oh, you're saying in PHP. I was like, wait, I think I have to. Because I can't do a variable allocation in a case statement. Technically, this shouldn't even be here. So we'll just move that up and out. Eternal Wild Fox says, indeed. Yeah, in PHP, you don't have to worry about memory allocation. It's garbage collected, if I remember correctly. Which is a large help, honestly, to not have to think about like, oh, I malloc this, must free. And then after we're done with all the things, I believe we can register free the register. What else do we allocate? So we get like the register, the CodeGen context. We can probably get rid of that thing. I don't think we have CodeGen context free yet because we don't have environment free yet. That's right. Well, that's not good. What did I just change? Big problems, apparently. Just from this one line? Or is it something else? Yeah, it's just that one line. So register free is broken. To do. This is broken. Eternal Wild Fox says, yes, PHP has a garbage collector. Nice. Garbage collected languages are the nicest to work in, honestly. Anybody who tells you otherwise is they're they're not, I don't think they're right. To do. This breaks things. But we should do it. Alrighty. So our program will always return 0 in this case. We should probably have a way to like set the return value. Ooh, what would be good is to have like some specific variable that's named like ret, or maybe like main out or something. So we would just have like main out, right? And it would just be dot space 1. We just want a byte. But if we get like main out, then at the end, instead of moving 69 into racks, like some hard-coded value, we could move main out rip addressed into racks. Which would, well, that's the address. That would give us the address. So we have to dereference that address. So we'd have to like do this. Something like that. And then that, in that case, anywhere in the program, you could set the output and exit and just jump here and it wouldn't be a big deal. I think that's a good idea. Okay. Okay. So we did a lot of CodeGen today. We redid the entire thing and it actually works. Hey, my stomach. Gotta love it. So I would like to delete this somehow. Is that even possible? Whatever. In OBS, I made a new audio source when I panicked earlier and you couldn't hear me. I was like, ah, they can't hear me. Make a new audio source. Do it fast. But, you know. And I got the old one working. Well, me creating the new one got the old one working. I didn't really do anything. Okay, so this is good. We're starting to generate programs. And we have the syntax and the ability to create lambdas. We just have to allow, we have to keep track of the lambda, yeah. So function, I guess it would be when I'm generating an expression. So if it's a function and we're in the parent context, we can just move on, right? So if it's a function, if context parent, then just break. Otherwise, do more stuff. So if we're in a nested context, then to do would be generate lambda. I guess we can just do that because we have that ability. The chip 8 also supports call and return, meaning functions are an option. Booyah! That's awesome. Landar XT pops in, says, oops, forgot to watch stream. It's all good, Landar. How's it going? There's always the VODs. Eternal Wild Fox says, yeah, the chip 8 supports call and return. That's very interesting. So we'll be able to port this to chip 8 relatively fast. I'm thinking about making like a custom syntax to be able to extend the backend so that you could actually, like, in the program itself, change how it generates this stuff. I know that's very complicated and we're absolutely not there yet, but I think it would be interesting. So a node type function, we're going to have the same type of thing for variable declarations, right? Because a variable declaration at the top level is a global variable. So to do global variable declaration, which is like get stack offset, stuff like that, right? Yeah. Just allocate space on stack. Keep track of RBP offset. Cool. Landar XT says, can't be messing up my daily streak. It's true, it's true. We'd love to have you here, so I appreciate it. I appreciate you coming in, even if it's a little late. It do not matter to me. That lurk. Still gotta find that lurk emote, wherever that is. Okay. So a function not at the top level. So yeah, we're just gonna say to do global variable declaration. Local, not global. Yeah, sure. We'll do something like that. Landor XT says, when Twitch automatically makes resolution 160p. Wait, is there actually transcoding? That'd be dope. If you actually have different resolutions available, that's awesome. I'm streaming at a lower bit rate than I normally do. I went down. I listened to the folks. So I can go down. I can go lower. I can go way lower. So this, we just have to do our function thing. How do we, what is it? This. We have to do this. It's a little bit, yeah. But if we actually have transcoding in the stream, that would be kind of dope. I'm not gonna lie. So these are all just gonna be what they're called. It works like 50% of the time. Lamau. That sums up how Twitch works in a nutshell, right? To do. Keep track of lambda, local lambda label in environment or something. Right. So label equals label, generate. And we'd like to use that label. Again, we should say result equals label generate. Which function? That would be expression. And code is the same. I don't think that's too bad. Implicit function declaration. Because CodeGen function calls CodeGen expression, it has to be below. But because CodeGen expression calls CodeGen function, so I think we're just going to have CodeGen function have a little prototype, a little bit of a forward declaration. Forward declare CodeGen function or CodeGen expression. I don't think that's too insane. It's not the best, but it's not too insane. Okay, so with that, where were we? So now we can CodeGen a function. We should say if error.type return error. And now we should be able to have nested function declarations. now we just have to be able to create a new syntax for creating functions. I actually thought about this a little bit, and I think lambdas and functions in general are not going to have this syntax. Functions are now going to be done like this, with the argument list and the body within these brackets. So this little syntax should be able to be used anywhere, and this will create a lambda. So this is the argument list, and then this is the body, right? A equals 25, and then like return A or something, right? So the idea is that this would be how we define lambdas, and functions are defined in the same way, just you give a function a name, right? I think that's pretty sensible. So if you don't want to name it, you can just do that. But if you want to name it, you can have this. And I think that's a sensible syntax. It's not the greatest, but it's not the worst, I don't think. Because looking at lambdas like this is not too bad, right? In any case, this is a to-do. Support this lambda syntax. It'd be cool to have special to-do comments that the compiler could collect for you. That's a good idea. We'll add that into our to-do. Have compiler able to collect to-do comments and things from source code. This would allow compiler-aided software design in more scenarios. Perfect. So we have a to-do, support this lambda syntax. We would like to do that, right? Then we also have to-do allow function assignment or something like that. When you make a to-do to add a to-do, it's true. It's so true. That's literally what this is. So we have a new lambda syntax that we're going to have to parse into a function. It's not going to be difficult. We have a new function assignment, which once we have this lambda syntax parsable, then this function assignment is going to be really easy. It's just a variable reassignment type function with a function, right? Pretty simple. Phone may have just, yep, okay. Alrighty, just had to deal with a little bit of a message. I see in the Discord now, I see Landar said earlier, doing an OS upgrade should be able to watch stream later. You upgraded your OS? Did you just do like a version upgrade, or is it did you switch to a new one? Nolan says, I shamelessly followed a YouTube video, but it's my first start building a Lexer. Ooh, let's go look at this on stream, because that's interesting. Look at this. So Nolan, in the Discord, posted this screenshot, and you can see that he actually has... Are those parentheses? Oh, Lord. These look very similar in this font. Anyway, he's got math working. 400 plus left paren uint 4. So this is a Lexer. You're starting a Lexer. That's pretty good. So 5 gets turned into a token 5. 420 plus 69 gets the 3 tokens. This is pretty good. It's not a streaming Lexer or anything, but this is a very good start. Because from here you could add, this is a parse tree effectively is what you've built, a flat parse tree. And then you can loop over this and parse it into nodes, into a non-flat tree, right? Eternal Wild Foxes, that is cool. Yes, yes. Alrighty, so to do would be to support these things. So let's do x integer x. Be like an identity lambda or whatever. And then also that's not kind of urgent. That can move down to miscellaneous. How did this happen? That's better. Okay, jeez. Headings got all off for a second. The other thing would be, what is it? Oh yeah, so return values. Let's think about how return values are going to work. Absolutely no one in any Discord has commented on my profile picture changing to the Phantom of the Opera, Lamau. So many people have so many pictures, I honestly don't even look at them. So I am sorry. I should pay more attention. That's a cool one. Stand by. It's like VHS. Gurmitu Parsabor as a lion. It's pretty dope. We got VMe with his Reddit avatar. I should look at those more. So this label, we would like to keep track of it by like creating a symbol in the environment or something, but I don't actually know how to do that. Because in the future, so the only way to call this lambda I'm confusing myself a little bit, but in a lambda, this isn't like a stack-based language, so you can't have like the lambda definition and then AR equals 420 and then do a call. Like that won't work because this is separate from this. We need to parse them together. So we'd have to parse a function call like this or a lambda call, in which case I think we could specifically look for that case when parsing a lambda, look ahead for a call, and then deal with it. I don't think, right? Because while parsing, what if we just assign a lambdas a name while parsing? That's not a bad idea. That's not a bad idea either. Just generate like even just a number for every lambda, a unique number, and then we could generate a label from that. Does that make sense? That makes sense, but then because calling it, we're only ever going to call it like right away, if that. But I guess if we're able to call any object, which should be the idea. So this means that we may just want to call the result variable. Like what if this moves the label, the address, right? Like whatever we would generate, like .l01, .l1 or something. So what if this generated that label? Well then, in that case, we could just get the last label that we returned, which I think is doable. So get the last label that's returned and jump to that. Or, here's the thing, we could generate this label, and then when generating a lambda, so when generating a lambda, we could also, oh god, say, okay, so after, jump after foo. Well, in this case, we would like to, so evaluating, a lambda should probably move its, yeah, so we do something like this, into result register, right? Whatever this is, an allocated result register, we would move foo rip addressed. Does that work? Can we do rip addressing if we're going to use this in a different instruction? Or is that wrong? That may be wrong. I don't know. We'll see. We will see, we will see. But in any case, if we do this, then that means a lambda, when it's generated, will actually set a result register, which if we have a function call in the parent, we can then just use the result register and call that. So a function call node will just needs an expression that puts a memory address of a function beginning, a procedure start, into the result register. That makes sense. That's making sense. So the idea then is a function call with a direct lambda instead of a symbol. See, a symbol will just look up the, we'll do our like symbol to address conversion. But if it's a literal function, then we will use the result register of that function, like this. So then a function call would be result register, dereferenced. So this memory address would then be called, we jump here and do all this thing. I think this allows for lambdas to work. And it means that, yeah, that allows for that to work. So this is going to be like lambdas. Sure, we're just going to put that there so that I don't forget what this is. Alrighty, good enough. Good enough. But yeah, that's what we have to do next. I don't know if we have time today, which is why I was kind of just conceptualizing everything and going through it. But we entirely reworked CodeGen, and it is now so much better. We don't have all these useless functions and all these like control flow confusion. It's not too bad, right? It's not too bad. We effectively just have a way to generate a lambda function, a way to generate the main function, the program, and a way to generate expressions. So the cool part about this whole system is it actually supports math. So all we have to do to start supporting binary operators is to actually insert them in the AST. And then we can set our, for example, our result register or our integer becomes this register, right? So then for both sides of the integer operator, right? If you have like 2 plus 2, so you'll do all of the children, don't quote me on that. You will generate code for each of the node's children. One's an integer 2 and one's an integer 2, right? So then you say, okay, both of these nodes, these integers have been moved into registers. And then you just use these two registers to add together. So node type add would just be like expression, result register, equals, first of all, we'd like generate children or whatever, right? Do that thing recursively. But then we just say result register can actually equal one of the registers that our children is, because the add instruction in assembly only takes 2 parameters and it adds into the second one, if that makes sense. Heyo. So this would overwrite RBX with the racks added to it, if that makes sense. So it doesn't have like A plus B equals C. It just has A plus B. B is equal to A plus B. You know what I mean? It's kind of confusing. It overwrites itself. So it's a destructive instruction is what that's referred to as. So the result register actually gets set to the one of the children's result registers. It doesn't matter which. We'll set it to the first child's. And then we can just basically add, right? We would do an add of whatever our result register on the left-hand side is, right? And then whatever it is on the right-hand side. I think I did that backwards based on this, so I'm going to do next child in here. So you can kind of picture this. What's the issue? I see. So we just have to do register name, is what I'm forgetting. But if you can see this, you can kind of see how adding would work. You effectively just get the register name again of R. And then you would just add the first register to the second register, and that's your result register, right? Whatever this one is. And that would just be it. That's an add. That would support it pretty much as long as they're integers, right? You'd still have to do type checking to ensure that you don't add things that aren't integers, but that's it. That's an add. So we are at the point where we have this CodeGen system that allows for us to actually generate code in a sensible way, which is good, We're probably going to need more than 3 scratch registers, so we'll have to decide what to deal with there. And what we could do is have local scratch registers as well, effectively. In which case, like when register in a context where arguments are not being used, for example. Yeah, in a context where arguments are not being used. So there's 4 registers in Microsoft Windows calling convention that are just used for our passing arguments. So to be able to use those as scratch registers would gain us a lot, obviously. And every function that doesn't have more than 4 arguments, well, you can just use them, right? It doesn't matter. So that's a good idea to start to take that into consideration. In any case, we also need some way to store locals in a register. That's something else as well. LandRXT says the compiler just built successfully for me on Linux. Heyo! Yeah, it should be cross-platform. Everything we've written has been with that in mind. But this compiler is now on Linux. Hey, haha. That's really good to hear, LandRXT. And it's awesome you're running it. Thank you. That is very cool to hear. We're going to do a commit the committed just for you. So we did a bunch of CodeGen. We have some to-do things to do next. Okay. Yep, that's good in the parser. Oh, I did not look at main.c. I just pressed S. Yep, that's fine. Okay, and then CodeGen got overhauled completely, and we can upload that. So let's make a commit the commit and say CodeGen overhaul. Why not? We'll do it this way for a little more of a celebration. Look at that. Overhaul CodeGen. Woohoo! We did it. CodeGen was unnecessarily messy and a terrible API, really. That would not have even worked for basic math expression. This new system, time to buy a Mac to test it on there, LanderXT says. Honestly, it should work on Mac. We don't really use much other than a C library, and Mac is Unix-based, so file everything should be normal. It should work. It should work. This new system allows for all that and more. Shout out to, what is it, Douglas? What is his name? Douglas Thane. Thane for making the following video. It helped me greatly. Helped me understand code generation and what problems need solved. Oops, that's his name. That's the, there we go. PushQRDX says, or just run macOS in in QEMU. Landar says, well, that would just make too much sense. He's right. You can't start making too much sense. It's dangerous. Shout out to Anita R for making the following video. It details the overall structure of a compiler and specifically CodeGen issues. Why not? But that helped a lot. Okay, I think that's doable. And I think that's a good message. We're going to commit the commit and push it. It's pushed. Our code is live. Go ahead and go down below to that GitHub link and check it out. In Landar, you're going to need to do a git pull. Git fetch and a git pull. I think git pull does a git fetch and then a git merge, if I'm not mistaken. That's what git pull is. Yes, currently, so you need some local binding that refers to a register versus we need some local binding that refers to a register versus a base pointer offset. I think that's just a symbol. I don't think that's too difficult. LanderXT says 5 files changed, 326 insertions, 231 deletions. Hey! Pog. I think those are the numbers. Hey, Pog. We did it. Very cool. CodeGen.c got that growth, though. So cool. Alrighty, so we are now generating code.s. Not too bad. And we can assemble, link, and run with no issues. And if we were to change this, of course, it would be that. Oops, nope, don't recompile. Just recompile. The other recompile. Shell command succeeded with no output. I wonder if it can't be higher than yeah, there it is. It can't be higher than 255. It's got to be 1 byte. That makes sense. PushQRDX says, wait, how is Megit fast for you on Windows Emacs? It's called Git for Windows. No, I think that's a great question. Let me make sure I don't dox myself. So I used to just use GitHub Desktop, which is terrifying, right? But eventually I wisened up and I was like, okay, I can actually choose what to do here. But Maggot in Emacs just uses a, we take a look. Can we, Control H, here, I'd like to customize group, I think, and then Maggot. Commands, question mark? So somewhere in here, there's like the actual executable. Somewhere. It's in one of these, but it's the actual executable. Maybe it's in Maggot process. Yeah, here. So you can see that you can set it custom. And you can also have like Sigwin mount points and everything. It's very smart. But this Git executable, I actually changed it so that my path contains Git for Windows first, if that makes sense. So, yes. Basically, the Git it runs is the proper Git and not the one that comes with, like, min-gw. Because the Git that comes with min-gw is rough. Right? It's very rough. And the Git that comes with, like, Visual Studio is not built. Not... It's like, it's a different thing. It's all integrated. But on Windows Emacs, Maggot is fast because I use Git for Windows, which is like a whole custom Git tool chain, which includes like all these different executables. Let me see if I can find it. I gave up once. I can try again. I don't even know where it would be. Is it in program files? Like, I installed it so long ago. But yeah, I basically just installed Git for Windows, which is a whole separate thing. Like it's a tool chain. Let me see if I can just find the website then. Maggot on Windows was stupidly slow. Yeah, it is very stupidly slow, but out of the box. But using this thing here, it's actually it actually works. They're correct. They do bring that SCM to Windows. But yeah, it's fast. You get a whole custom like bash emulation, so you can run bash scripts, and it's honestly great. It's great. I don't use the GUI at all, but I do use the shell integration, where in the Explorer, whoops, I can like right click on a program or in a folder, for example, and then I can just open a Git GUI here or Git bash. And I'm like, oh, Git status, not a Git repository. That would be an issue. Hey, my stomach. Oh, I gotta do 2022. But yeah. See how fast that was. It's fast on Windows. Had no idea Git for Windows had a GUI. Yeah, they've got a whole thing. We can check it out. Oh, I'd have to actually go to one. But it's pretty good. I wouldn't say it's bad. The whole time I thought you were using WSL or something. No, WSL is slow with the file system, and Git works with the file system quite a bit. But yeah, you can see this is their little UI. It's not great, but it's not the worst, you know? And what I really prefer is this database statistics. So if you have loose objects in your Git GUI, your actual Git repository can be like way bigger than it needs to be. So you can compress the database here and make it smaller by packing objects together. And then there's also visualize. There's this, which is Git K, and Git K is like a visualization GUI. So you can see the Git history of, for example, the fun compiler here. And I think we can load all sorts of things. But yeah, there's all sorts of things that Git for Windows comes with. It's pretty nice. I don't use those. I just use the use it through Emacs and Maggot. Because Emacs is best. Emacs is B. But yeah, fun compiler. Alrighty, I think we have nothing to do. Today is starting to come to an end. We could start some more of this, or some, ooh, what is this? Bind all arguments to a function, parser.c, line 570. I don't think I've seen it. Have I actually fixed this? I haven't. Hey, look at us. We're screwing something up. We have an iterator and then we're not looping over it. Aren't we silly? We can do one last thing in the stream. PushQRDX says, I used to run Git GUIs, but Maggot replaced them for me. I also like to use lazy Git sometimes. Nice. I had literally the exact same experience, where for a long time I used, what is it, Git Kraken? Apparently. It's not here though. There it is. But yeah, I used to use Git Kraken all the time. And I kind of liked how it sounds. Like, you better get cracking, get going. Right? But yeah, once I found Maggot, it was like, I never have to leave Emacs for anything. It's incredible. Alright, everything worked. And the code we generated is the same. But now we should be actually doing that thing we said to do. means we can make it a done and be done with it. Yeah, we should still make the AST grow larger. Store the actual token for each node within the AST, so the spans kind of work like a rope does. PushQRDX says lol. Lol 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 lol. That's good though. So now all the arguments to a function, what is this? Parse return type. Yeah, so while we're parsing the function body, that's not parsing the function body. While we're parsing the function body, these will now be bound in the environment as variables with the proper type. And then at the end, we should say context equals context parent, right? In defun, I'm sure. So I think here, to do, should we pop parser context here? Question mark? Because if we break, we're just going to go around again. Not the best idea, I don't think. In any case, our programs are starting to come together. You know what I just realized would be interesting as well? What if we accepted... Oh, that's dirty. What if we kind of had like the AST is able to be represented in the program itself? Kind of like Lisp works, but Lisp, it's just the same thing. Hello, kitty. Hey, look, the cat is on stream. The cat's never been on stream. How are you, kitty? If you don't know, I have a hairless cat. So there right now on my lap, there is a demon abomination that that has no hair. Oh, but she's so cute. It's okay, kitty. We can still code. We can end the stream. Oh yeah, I got a feeder for today. Yes. All right. I'm getting distracted. Effectively, we had a great day today. We gained one new follower, Night Nazar, sorry. And we entirely redid the entire code generator. We have that push to Git. We kind of have everything done. This is incredible. So now what we need to work on next is probably actually expressions and math and adding some more types into this system. And, oh, first of all, we should probably add type checking. We should do the type checking stage next. But after that, we will have completely finished a compiler from end to end. Then we have to write our end-to-end tests in Algol 68. I forgot about that. That's going to be fun. That's going to be a lot of fun. Anyways, thank you everybody so much for watching. I very much appreciate it. Be sure to hit that follow button if you enjoyed and want to see more. We are 4 followers away from becoming Twitch affiliate. We're so close. Thank you everybody so much for following. And when we become Twitch affiliate, LanderXT says you better find some more compiler features to add. I'm assuming this is going to be a 100-part series. I want to put 300 hours of work into this compiler. So if you are okay with that, that's my plan. My plan is to work a lot on this. But yeah, thank you everybody so much for watching. Hit that follow button. We are so close to Twitch affiliate. We will get channel points. Just for watching, you'll get points. Ain't that fun? You'll be able to cheer bits. You'll get custom emotes. Eternal Wild Fox says, mwahaha. And PushQRDX says, sweet, I am in. That's right. It's like Rick and Morty, season 9. Season 9, that's my whole arc, Morty. That's my series arc. Season 9, the compiler. Morty. LenderXT says, if you let all of us help, we could probably make it a serious language. Well, I will absolutely accept pull requests. We'll look through them on stream, do code reviews, and we'll merge pull requests. Hell yeah. That would be a lot of fun. I just have to, if we do that, I have to kind of write a, like what the language should do and what it should look like, for example. Because then people will I don't want people asking me like, can I add this feature? You know what I mean? That's everyone asks. It's like, I want to kind of have a definition of what the language should be able to do and be. Lander XD says, I'm going to make a PR just to add 10,000 lines of comments. Lamau. If you can justify it, I would accept it, but if you can't justify it, I wouldn't. That's going to be a lot of fun, though. This is absolutely completely open source. Feel free to make any pull requests, changes. You can do whatever you want with that MIT license. But yeah, thank you everybody so much for watching. I greatly appreciate you just being here. I appreciate all the lurkers that are not chatting. I appreciate all the chatters who we get to talk with and make positive memories with. And we got the even the people who aren't watching. I thank everybody who has ever watched because you're a part of why we're here right now. So thank you. Down below, you'll find a YouTube link, and on that YouTube channel, you will find VODs or videos of every single broadcast I have ever done on this channel. I really recommend it if you would like to see any previous videos, and there's plenty of stuff to look at there, right? LanderXT says printf hello world. This shows how a simple function can be used in something so complex as a compiler, and make sure the code can be 100% reliable, even with such an old function. Lamau. Just have, like, comments that aren't needed and are way too long. But yeah, thank you so much for watching. Be sure to check out that YouTube down below. Check out the Discord, where we can actually all hang out together. We have a lot of fun, share our progress. Eternal Wild Fox is typing right now, even. And yeah, get announcements every time I go live. I really recommend it. We all have fun here. We all help each other out. And yeah, also check out that donate button down below. If you would be so kind and so generous, I would greatly appreciate any and all donations. I thank everybody that has watched, anybody that is watching. I'd like to especially thank Victor, V_me, and Steve, SF. I'm saying first names now. And Steve, SF, are 2 official donators so far. So thank you so much, everybody, for watching. Be kind to each other. As Bill and Ted said, be excellent to each other. And party on, dudes. And I think that's great advice. Be sure to follow that. I'll see you next time. Probably tomorrow, working more on this compiler. We're going to get to part 100, Morty. We're going to get to part 100. It's going to be amazing. Morty. Oh. Morty. Part 100. This is my series arc, Morty. The compiler. The compiler, Morty. It's got to make programs. Anyways, I gotta go. Bye. End of season 1.